Section 3.2 is all about graphs of equations. And if you have a graphing calculator, it'll make this section much easier to deal with throughout the whole entire thing. In any graph of an equation, at times you may get a graph that does this and then goes back like so. Some of the important parts of it would be these two coordinates, which cross the x-axis, and so they are called x-intercepts. In an x-intercept, the coordinate is some value, comma 0. What that value is all depends on where it crosses the x-axis at, but the y value is always 0. And then there's a coordinate here where it is called the y-intercept. And there can only be one y-intercept if it is a function, and in that case, the x value is 0. And then the y value is wherever it crosses at. Now sometimes the graph may be moved up there and then it would have no x-intercepts, but it still has a y. And there are other instances where maybe it does not have a y-intercept either. It all depends on what the function is and what it looks like. Now, as an example, if you had y equals x squared minus 5, which is not this graph that I have drawn here, this is a graph of a parabola, which would be something like this. If you wanted to find the x-intercepts, then you would have to make y equal to 0. And now try to solve this equation by adding 5. And then taking the square root. And x equals plus and minus the square root of 5. And so then our x-intercepts would be the square root of 5, comma 0, and a negative square root of 5, comma 0. If you were wanting to find the y-intercept, you would do the same thing, except in this case, you would substitute a 0 in for the x value. So you would get y equals 0 squared minus 5. Solving that for y, 0 squared is 0, minus 5 is a negative 5 for an answer. And it'll ask you to do that on occasion. Second thing about graphs of equations, are there some things dealing with symmetry? If you are talking symmetry with respect to the y-axis, if it's y-axis symmetry, then the opposite of x and x have the same equation. Or the opposite of x and x have the same value all the time. If you were talking x-axis symmetry, then the opposite of y and y have the same value or same equation. And then there also can be origin symmetry. And in that case, the opposite of x and the opposite of y have the same equation. Examples of these three types of symmetry. If you're talking y-axis symmetry, An equation like y equals x squared minus 5 would be one that has y-axis symmetry, because when you graph y equals x squared minus 5, it would look like this. And so, to show it, you know you have this y equals x squared minus 5. So then if you substitute in a negative x to this equation, when you take a negative and square it, you would still get x squared minus 5. And now, since those two things are the same, they're symmetric to the y-axis. If we have x-axis symmetry, that would be something along this line. And when you substitute in a negative y and simplify, you're going to get x equals y squared plus 4 as well. And so now, since those two things are the same, they are x-axis symmetric. And for origin symmetry, something like y equals 2/3 x cubed would be something that's origin symmetric. And what you have to do there is substitute a negative y in and a negative x. And then simplifying this, negative cubed is still going to be a negative x to the third times 2/3 equals y negative. When you multiply 2/3 times a negative 1, you'll get a negative 2/3 x to the third equals a negative y. And then getting y by itself, you would multiply by a negative 1 to get y equals 2/3 x cubed. Oh. And now those two things are the same. And so they are origin symmetric. Next, you'll see things dealing with circles and the graphs of circles. General form of a circle is this right here, where it's x minus h squared plus y minus k squared equals r squared. Now, what do all these letters mean? Well, r stands for the radius of the circle. H, comma k is the center of the circle. And so the opposite of this value, so if you have like x minus 2 squared, then your center would be at 2 comma something. And then if you had plus y minus or plus 4 squared, then it would be at 2 negative 4 is the center of our circle. And if this turns into a plus 2, then it becomes a negative 2 negative 4. Now, if we multiply this all out, square that thing, you would get x squared minus 2hx minus h or plus h squared, and then plus y squared minus 2ky plus k squared equals r squared. And then combining the things that you can, because this right here is just going to be a number, so is that, and so is that. And so if you bring it all to one side, you would have 0 on that side and get x squared minus 2hx plus y squared minus 2ky plus h squared plus k squared minus r squared. And if you group all of that together, that's just going to be a number. And that's another way to look at it. And what you're going to have to do when it's in this form is you're going to have to convert it to that form in order to figure out everything. Now, how do you convert that? Well, we'll get to that in a moment. First, though, let's look at an example here and figure out what we have. So we have x plus 2 squared plus y minus 3 squared equals 16. So we know that our center is going to be at a negative 2, positive 3. Right there's our center. And we know that our radius is equal to 4. So that means 1, 2, 3, 4. And there you have your circle. And so then we can draw it. And there you have it. Now, you will also get a problem where you have a circle drawn and you have to figure out the equation for it. So if we look at this, the center of our circle is here, which is 5, 6, 7, 8, comma, negative 1. So because the x value is 8, we'd put x minus 8. Y value is a negative 1, so y plus 1. And now the radius of our circle is 2. So then we would have to put 2 squared on the other side, or just make it 4, because that's what 2 squared is. Now then, taking an equation like this and trying to figure out what the radius and the center of it would be, you are going to have to go through and do a bunch of different steps. And that process involves complete the square. To do that, you want to group the x's and the y's together on one side. And put everything else on the other side. So because we have 2x squared and a negative 12x, those go together as 2x squared minus 12x. And then we have 2y squared and 4y, so plus 2y squared plus 4y, and then equals 15, because we want to move the 15 to the other side by adding it. Then, once you get that accomplished, the squared terms coefficient must be 1. So because it is 2x squared right now, we need to get it to be 1, so we would have to divide by 2. And if we're going to divide that by 2, we have to divide everything on this side by 2 as well. And we also have to divide the other side by 2, because if you do something to one side, you must do it to the other. And the other thing about this is both squared terms should have the same coefficient. It's not a circle if it's not that way. So when we divide this by 2, you would get x squared minus 6x plus y squared plus 2y equals 15 over 2. Third thing, to complete the square. Here's where you do this. And to complete the square, you take half of x term, And you're adding that squared to both sides in order for you to do this. Okay, so to complete this square, I'm going to write that. Just look at the x term, and half of negative 6 is a negative 3, so it's x minus 3 squared. Well, in order for us really to write this, because if you multiply this out, you get x squared minus 6x plus 9. What's missing from here, from this, in this thing, is the plus 9. Well, that's 3 squared. So what we're doing is having to add 9 to this in order for us to factor it to x minus 3 squared. So because we did that, we added 9 here, we are also going to need to add 9 to that side. And then we have to do the same thing with the y's, except here we're not taking half of the x term, we're taking half of the y term. So we put parentheses and squared, y plus half of 2 is 1. Well, now 1 squared is 1, so then we're adding 1 to this in order for us to factor this whole thing down to that. You have to add 1 to it, which gets you y plus 1 squared. So then we add 1 to the other side as well. And now adding all of this up, you will get 35 over 2. And now we have it in the proper form. That's the process of completing the square. Group the x's, group the y's, put the coefficient number on the other, or the constant number on the other side. Make sure the x squared and the y squared terms have a coefficient of 1. If they do not, divide everything by that number that's the coefficient. Then once you get it down to having a coefficient of 1 for both, take half of the x term and write your factor, whatever number you use here, square that, and that's what you add in to both sides of your equation. Then do the same thing with the y values. Take half of the y term, square it, add that to both sides. Now that you have it in this form, you know that the radius of our circle is the square root of 35 over 2, and the center is at 3, negative 1. Finally, we have to deal with some semicircles, which are half of circle. Two ways to look at it is if we solve for y. In order to solve for y, you would first take the square root of this, take the square root of that, and you would get y minus k equals plus and minus the square root of r squared and then minus x minus h squared. Now, where did this equation come from here to begin with? Well, that is this equation right here. I just took this part of it and moved it to the other side by subtracting it to begin with. All right, so we're left with that equation. And then finally, we would take and add k to both sides to get y equals both positive and negative. So we're going to write the positive one here, r squared minus x minus h squared plus k. And we would also have y equals negative square root of r squared minus x minus h squared plus k. Now, everything still stays the same. R is still your radius. H comma k is still the center. And in this case, well, it's the opposite of h, and then k is what it is. Because it is a semicircle, this one's the positive, and since it's y equals, it's a function, so it's a positive semicircle, which means it's the top half of the semicircle. When it's a negative, that means it is the bottom half of your circle. Now, if we flip-flop this and this, then you would have x minus h squared equals r squared minus y minus k squared. And now again, if we solve for x, in this case we would take the square root of both sides to get x minus h equals plus and minus the square root of r squared minus y minus k squared, and then adding h to both sides. And we would get two things here. One would be x equals positive square root of r squared minus y minus k squared plus h, and y equals the square root of r squared minus y minus k squared, and it would be a negative and still plus h. And so then again, in this case, our radius would be r, and our center would be at h, comma, the opposite of k. Whichever thing is in parentheses, when it's in parentheses like this, it's the opposite of that value, whether it's here or here. Now, because this is x equals, when it is positive, it is the right half of a circle. When it is negative, it is the left half of a circle. And now in looking at a couple of examples, our first one here is x equals a negative square root of 16 minus y squared. So because it is x equals, we're talking about a semicircle that is either a right or a left. Because it is negative, it is that one. Radius of our circle is 4. There is no value with the y, so the y value of our center is at 0, and there is no number outside, so the other part of our center is at 0 as well. So we have 0, 0 as our center, and our radius is 4. And so our semicircle will be this. Of course, yours would go exactly from there to there and look just as nice as that one. In our second example over here, we have 4 as that number, so the radius is going to be 2. And because it's x plus 2, then our center is going to be at a negative 2, negative 1. Because that number on the outside, you use it. This one, you use the opposite. And so, negative 2, negative 1 is our center. Radius is 2. And because this is a y equals, it's going to be either this part or that part of our circle, and it's the positive one. So we're dealing with the top half of our circle, which is here. And then you could also get an equation or a graph of a semicircle and have to come up with the equation. So first, where's the center? Right here. 1, 2, 3 to the left, and 6 up. And the radius of this circle, or semicircle, is 3. Now it is the top half of a circle, so that's going to be y equals. And since it's the top half, it's a positive. The square root of The radius is 3, so in the equation we would put 9 minus, in parentheses, x plus 3 squared, because since y is on this side, x has to be on that side. And then since our other part of our center is 6, we would put plus 6 after it. And that concludes everything from section 3.2.